ಒಂದು ಸ್ವಲ್ಪ ಒಂದು ಜಾಸ್ತಿ ಪ್ರಾಕ್ಟೀಸ್ ಬೇಕಾಗ್ತದೆ.
Good morning. So today we are going to discuss about the center of mass. So center of mass is nothing but it is the point at which total mass of the body is supposed to be concentrated. Center of mass may lies inside the body or outside the body. For example, see here ring. In this case, center of mass lies inside the body. Sorry, outside the body. And here inside the body. What is the meaning of that one? So it means that, so here mass may exist or may not exist. So in this case, at this point, the center of mass, here mass is not existing. So at this point, mass is existing. So one more example, if you are taken, so horseshoe, for example, this one, if you consider, where center of mass lies here? Center of mass lies at this point somewhere. So it means that the center of mass at this point, mass is not existing. So it means lies inside the body or outside the body. So it is a center of mass. So for some example, we'll discuss here. So this is first one, circular ring. So at which point center of mass lies here? So at the center, at the center of the ring. So similarly here, circular disc. Circular disc, at which point center of mass lies? It is also at the center of the disc. So next, triangular plate. At which point center of mass lies here? At centroid. Centroid of the triangle, center of mass lies. These are the three examples. So we'll discuss a few examples. Now square plate. So square plate, where center of mass lies here? So at the point of intersection of the diagonals. This is a square plate. Next one, rectangular plate. So rectangular plate, so same, it is also at the point of intersection of the diagonals. So center of mass lies at this point. Now hollow or solid sphere, at the center of the sphere, at the center of the sphere, at this point center of mass lies. Next, hollow cone. Hollow cone, this one is base of the cone. So from here, at a height h/3 from the base. So from base, if you are going to calculate center of mass, that is at h/3. So one derivation I'll derive. So from vertex, if you are going to calculate 2h/3, this is the center of mass position. Next one, solid cone. Solid cone and hollow cone, so both are different. See, so at this point, so from base we are going to calculate. So at the height h/4 from the base. From vertex, if you are going to calculate 3h/4. Solid cone, solid or hollow cylinder. So this one is axis of the cylinder. So on this axis of the cylinder, center of mass point you will get. So where you will get? At the exactly center of the cylinder. So midpoint of own axis. This is axis. So at midpoint of this axis, center of mass lies. So next we'll discuss so where center of mass of an arc lies. So sometimes they'll give center of curvature. So from center of curvature, so we have to find center of mass. So this one I have taken a small arc. So this is the center of curvature of this arc. Radius of curvature is r. from this point, so this arc is subtended an angle alpha. See, arc of radius are subtending an angle alpha at its center of curvature. So from this point we are going to find center of mass. So OC distance, so at this point center of mass will be there. So you should know that where so mass is distributed, so towards that point center of mass will be there. So OC, so general formula is there. So general formula OC is equal to 2r upon alpha, so which is angle subtended by this arc sine alpha by 2. This is general equation. So we'll discuss some examples based on this formula. See, semicircular so ring, this is semicircular ring. So this arc, so this complete arc, how much angle this is subtending? Pi. So we know that formula, that is OC is equal to 2r divided by alpha sine alpha divided by 2. So this OC is equal to 2r divided by alpha sine, this is what, alpha is pi divided by 2. Okay, so this is OC is equal to 2r upon alpha. So alpha is what it is, pi. This is pi. Okay, angle pi. Sin 90 is 1. So this is your answer. So from which point it is? From point O. So where is center of mass? 2r upon pi. And one more example. Okay. So this one I'll take. This is center of curvature. How much angle it is forming? 45 degree. Okay, alpha is 45 degree. Somewhere where center of mass will be there, center of mass at this point. This is O and this is C. C is center of mass. This distance we are going to find. So alpha is 45. So we can write here, or pi by 4. OC is equal to 2r. So alpha is equal to pi by 4. Okay, 2r divided by pi by 4. Alpha value is pi by 4. Sine, this is alpha pi by 4 into 2. So this is OC is equal to, so this 4 will go to numerator. So this 4 into 2, 8r upon pi sine pi by 8. So this one. So like this, one more example also we can discuss. This is center of curvature. Okay, how much angle it is forming? 270, or what it is, 3 pi by 2. 3 pi by 2. So if you substitute this value in this formula, general formula is 2r divided by alpha sine alpha upon 2. Alpha value substitute here, so you will get so the answer. Okay, next, semicircular disc. Semicircular disc, so this we are going to find center of mass from O. So from here to here OC, that OC equal to 4r divided by 3 pi. So solid hemisphere, this is solid hemisphere. From this point the position of the center of mass OC is equal to 3r upon 8. 3r upon 8. So next, hollow sphere, hollow hemisphere we are going to discuss. That is, so OC equal to r by 2. Exactly half of the radius, center of mass, portion of center of mass we will get. So this is hollow sphere. So now here horseshoe magnet. So horseshoe magnet will get at its center within the boundary. So this is the boundary. Within this boundary, so center of mass will get. We can write here, within the boundary center of mass, portion of center of mass will get here. So here semicircular annular ring or annular plate. This plate, this one is the center of curvature of this inner radius and outer radius. So annular ring means we will have two radius, r1 and r2. So position of center of mass from a center of curvature OC equal to, that is 4 r1 square r2 square plus r1 r2 upon 3 pi r1 plus r2. So this one is, so formula for position of center of mass of annular plate. So next, coordinate of center of mass we'll discuss. So I'll take two coordinate first here, two coordinates. Okay, so this is first particle, second particle. So mass of this particle is m1, mass of this particle is m2. The position vector, the position of this first particle is r1, the position of second particle with respect to origin is r2. Somewhere the center of mass of first particle and second particle somewhere lies at this point. Yes, no, this is the center of mass. The position vector for center of mass we can write rcm here, rcm. The coordinates I'll write here, the coordinate x2 y2, and coordinates of this one is what, x1 y1. Then position of center of mass we can write rcm, general formula m1 r1 plus m2 r2 upon m1 plus m2. This is the general formula of position of center of mass of two particle. So here, if center of mass along x-axis, center of mass along y-axis, xcm ycm, if you are going to find, that is xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. This is the position of center of mass on x-axis, and this is ycm m1 y1 plus m2 y2 upon m1 plus m2. Okay, so I discussed by taking two particles. If you have taken n number of particles, what is the general formula? General formula of rcm is equal to m1 r1 plus dash dash first particle, like that. A large number of particles if you have taken, m and rn will get divided by m1 plus m2 plus, like that, so on, mn. So like this summation also you can write m I ri, I tends to I equal to 1 to I equal to n. If you substitute I equal to 1, you will get first term. If you substitute I equal to n, last term, like that you will get summation of mi. Similarly, I is equal to 1 to I is equal to n. And also we can write this one, I equal to 1 to I equal to n mi ri upon summation of m. It means that mass of all the particles we can write capital M. Capital M is nothing but mass of all the particles we can write. So similarly xcm also you can write xcm. So m1 x1 plus so on mn xn upon m1 plus, like that, mn. This we can write summation of I equal to 1 to I equal to n mi xi upon total mass m. Similarly ycm, so direct I'll write I equal to 1 to I equal to n mi yi divided by m. And zcm equal to summation of I is equal to 1. If, when we will take this zcm, if particles are lying in a space, so three coordinate system, in that case z coordinate also will come. Z coordinates, that is I equal to n mi zi divided by m. If that particles are lying on the plane means only two coordinates will come, that is xcm and ycm. So in space, if they are lying, so three coordinates will take. Velocity of center of mass. Okay, so velocity is nothing but rate of change of displacement. In this case, so rate of change of position vector. So this one. So here, if these two particles are moving together, the position of center of mass also will move. So rate of change of displacement is nothing but velocity. So this velocity of center of mass is equal to, so we can write that, so rate of change of RCM upon with respect to T. So this is a general formula in vectorical form I am writing here. So this one, velocity of center of mass is equal to, so we can write m1 v1 plus m2 v2 plus, if there are n number of particles, mn vn upon m1 plus m2 plus, like that, mn. So in summation form also you can write here this one, summation of I equal to 1 to I equal to n. So this, if all the mi vi vectorical form divided by this total mass is capital M. Okay, so vector sign indicates that direction. Okay, so next, if here one case I'll discuss here, if there are only two particles, if there are only two particles, what is the velocity of center of mass? Velocity of center of mass, this is vcm is equal to m1 v1 plus m2 v2 upon m1 plus m2. So magnitude we are going to find, this is vectorical form I wrote. So magnitude, how to find velocity of center of mass? Magnitude, that is square root of magnitude m1 square v1 square plus m2 square v2 square plus 2 times of m1 m2 v1 v2, and also we can write m1 v1 m2 v2 also we can write cos theta. What is the meaning of this one theta? So I'll tell you here. Okay, so if one particle is moving in this direction v1, another particle is moving in this direction v2, so both these two particles are making angle theta, then velocity of center of mass in which direction? This direction. Yes, no? So that velocity of center of mass, this is the general formula of magnitude of velocity of center of mass, m1 v1 square m2 v2 square 2 m1 v1 m2 v2 cos theta. Theta is angle between two particles. So case 1, if two particles are moving in same direction, so this is first particle v1, second particle v2. First particle mass is m1, second particle mass is m2. The angle between these two particles is what? Theta equal to 0. In this case, so velocity of center of mass, so once again I'll write here a general formula, m1 square v1 square plus m2 square v2 square plus 2 times of m1 v1 m2 v2 cos what you have to write here? 0, because angle between two particles is 0, m1 plus m2 vcm. This cos 0 is what? 1. So now this is the formula, we know that. So a square plus b square plus 2ab, we can write this one, m1 v1 square plus m2 square v2 square whole square upon m1 plus m2. We can write, if you expand this one, you'll get this term. Yes, no? a, a plus b whole square, a square plus b square plus 2a. So this square will get cancelled. See, after cancelling, we see m equal to, what will get here, m1 square v1 square m2 square v2 square upon, sorry, this square will not come here. Okay, so because this, if you expand this one, if you expand this one, this term will get, this square will get cancelled. So next we see m equal to m1 v1 plus m2 v2 upon m1 plus m2. Sorry, this square will not come. Okay, so this is general formula when, so both are moving in same direction. So if both are moving in opposite direction, if both are moving in opposite direction, case 2, case 2, one object moving in this direction, another object moving in this direction, mass of this one m1, mass of second particle m2, the angle between these two is what, phi. So then velocity of center of mass, we can write square root of m1 square v1 square plus m2 square v2 square plus 2 m1 v1 m2 v2 cos 180 m1 plus m2. VCM is equal to, cos 180 is minus 1, cos 180 is minus 1 m1 v1 square plus m2 square v2 square minus, I'll write here this one direct here, 2 times of m1 v1 m2 v2 upon m1 plus m2. So this is the formula. So a minus b whole square, we can write m1 v1 minus m2 v2 whole square. Okay, square root as it is m1 plus m2. So this square get cancelled, m1 v1 minus m2 v2 upon m1 plus m2. This is a velocity of center of mass if two particles are moving in opposite direction. So if they are moving in some angle means, so we have to take here this angle 45. So here in this case 45, 60. So anything they may give. So this is the, so motion of center of mass. Next, similarly, acceleration of center of mass. Same, acceleration is nothing but rate of change of velocity. So acceleration of center of mass, general formula in terms of vectorical form, m1 a1 plus m2 a2, like that. If there are n number of particles, like this we can write m1 plus m2, like that. Okay, so if magnitude, if you are going to find, same as that velocity of center of mass we discussed, no, same like that only, m1 a1 square, m1 square a1 square plus m2 square a2 square plus 2 times of m1 a1 cos theta upon m1 plus m2. So this is for two particles. So two particles, so if two particles are moving some angle, so like this, one particle is moving in this direction, another particle moving in this direction, what is the acceleration? If theta m1 m2, so acceleration of this one a1, acceleration of this one a2. So we are going to find acceleration of center of mass. This is acceleration of center of mass. First case, case 1 is if both are moving in same direction, both are moving in same direction means theta equal to 0. Theta equal to 0. So if theta equal to 0, substitute here theta equal to 0, final equation will get here ACM is equal to m1a1 plus m2a2 upon m1 plus m2, same as velocity of center of mass just now I did it. So case 2, theta equal to 180, both are moving in opposite direction. In that case, opposite direction, one particle moving in this direction, another particle moving in this direction. In that case, acceleration of center of mass is m1 a1 minus will come here m2 a2 upon m1 plus m2. This is acceleration of center of mass of two particles. Next, acceleration of center of mass in mass pulley system. Okay, here okay. So initially both these two objects are at this point. Okay, so initially when you leave that system, so which one is heavy that will move down and which one is light that will move up. Okay, the distance covered by this object, how much it is? Yes. Okay, so similarly this also yes. Acceleration of this one a, acceleration of this one also a, there is no change, but acceleration of center of mass changes. So in laws of motion, so we discussed this problem, acceleration of this object is how much, acceleration of this object is how much, what is that formula? Acceleration of that object is what? A equal to, yes, mass of this one is m2, mass of this one is m1, m1 is greater than m2. If m1 is greater than m2, what is the acceleration of individual objects? What is the acceleration of individual objects? Acceleration is equal to m1 minus m2 into g upon m1 plus m2. So this is the formula of individual actual acceleration of mass. So acceleration of this first particle, acceleration of second particle, both are same here. We are going to find acceleration of center of mass. So one object is moving upwards, another object moving in downward, both are moving in opposite direction. The angle between first object and second object is how much here? 180. If there is 180, what is the formula? Acceleration of center of mass m1a1 minus m2a2 upon m1 plus m2. So we can write here acceleration of center of mass is equal to m1 a1 I'll not write here because acceleration of first object and second object both are same, with same acceleration both are moving, minus m2 a2 upon m1 plus m2. Next, acceleration of center of mass a, take common m1 minus m2 upon m1 plus m2 a. Sorry, this is a is common. Okay. Next, acceleration of center of mass m1 minus m2 m1 plus m2. Substitute the value of acceleration of each objects. So here acceleration I am substituting m1 minus m2 divided by m1 plus m2 into g. Okay. Next, this is acceleration of center of mass, which is equal to m1 minus m2 into m1 minus m2. We can write m1 minus m2 whole square. Similarly, denominator m1 plus m2 whole square into g. Yes. So now if we are going to find distance here, distance directly we can find so by using kinematic equations, but here I am going to find how much that center of mass is displaced. center of mass. So I'm not going to calculate here. So distance moved by this object or distance moved by this object. Distance moved by this object is s, distance moved by this object also s. I'm going to calculate the distance moved by center of mass is how much. That is scm is equal to half a t square. This one is what here, what you have to take here, acceleration of center of mass we have to take here. This is acceleration of center of mass. If you are going to find so displacement of center of mass means here acceleration of center of mass we have to here see. So here displacement of center of mass we are going to find means here acceleration of center of mass. So this acceleration of center of mass from here we have to substitute. You will get the displacement of center of mass will get. Yes, position of center two particles. So first particle mass is m1, second particle mass m2. Distance between these two particles is d. If m1 is greater than m2, where will be center of mass? Towards heavier mass, somewhere here. This is center of mass. I'll take this center of mass at origin. So from here to here I'll take d1 distance, from here to here I'll take d2 distance, this one. So we know that the center of mass lies on x-axis. We can write xcm is equal to m1 x1 plus m2 x2 upon m1 plus m2. Xcm is at origin. We can write here. So okay, x1 equal to, this is our reference point. So I assume that center of mass lies at origin. Okay, we are measuring distance of this mass from origin. It means that d1 you have to take plus or minus here. So minus you have to take. Why? Because the left side of that origin minus d1. So x1 and x2 means what here? X1 is nothing but the portion of first particle from reference point. X2 is a portion of second particle from reference point. This is our reference point, and this reference point only assume that center of mass. Then x2 is equal to d2. Now substitute this one, and xcm equal to 0. Xcm is equal to 0. Why? Because I assumed at origin 0. Now 0, this one m1 minus d1 plus m2 d2 upon m1 plus m2. Cross multiplication, this one 0. So m1 minus into d1, it is minus m1 d1. Take this one left side, you'll get plus, that is m1 d1 is equal to m2 d2, m2 d2. So we got this equation. Okay, and here d equal to what you can write? d1 plus d2 we can write now. D is equal to d1 plus d2, because this total distance between first particle and second particle is so d. So d1 and d2 are the so distance from origin. So d1 plus d2 is equal to d we can write. Okay, now so I am using, we are going to find the distance d1 and distance d2 is how much. Okay, yes, I'm taking this one. d1 equal to what you can write? m2 d2 upon m1. Okay, from this equation or equation number 1, from this equation I am substituting the value of d2. m2 keep as it is. d2 can be written as d minus d1 upon m1. Yes. So from using this equation number 1 and equation number 2, we can find the portion of portion of first particle and portion of second particle. We can find. Okay. So next, after simplification of this d1 and general formula I'll write here. So d1 is equal to, we'll get m2 into, so d upon m1 plus m2. So this is position of first particle from origin, and second one the position of second particle, that is m1, position number 2. You'll get so this d1 and d2. So d1 is so distance of first particle from origin, d2 is distance of second particle from origin. Center of mass of rigid body now. So this is rigid body. So we are going to find the center of mass of this rigid body. This is our reference point or reference axis I have taken. So small element I have taken here, small element. The mass of this element is dm, and the position vector is r, like that. So large number of particles we can, so large number rcm, center of mass of this so rigid body is somewhere at this point or any, so assumed to be concentrated at one point, center of mass. The position of position vector for this one from here to here, rcm. This is the reference point. We are going to find the center of mass of this rigid body. So this is rcm. This rcm is equal to, that is we can write integration of r dm upon integration of dm. So if particles are distributed in discrete manner, in that case what will take, m1 r1 m2 r2 plus m3 r3, like that will take. But here the mass is distributed continuously. If the mass is distributed continuously, in that case integration will take here, integration. So r into dm, r is a position vector for this element from the reference axis rdm. So this denominator term is a total mass. So general we can write here. So r cm equal to integration of r dm upon, this one is a capital M also we can write. And coordinates xcm equal to integration of x into dm upon integration of dm, you can read ycm integration of y dm upon integration of dm. And next one zcm, if object is so if rigid body, you'll get 3 coordinate if object in a space, in that case z dm upon integration of dm. Okay, so these are the 3 coordinates for center of mass, xcm, ycm and zcm. So when you have to use this one, if mass is distributed continuously, if mass is distributed continuously, we can use this one. xcm, center of mass lies along x-axis, y-axis and z-axis. One example I'll derive here, starting directly a given formula, but here this I'll derive here. See, so this is a cone, solid cone. So the solid cone, from vertex one formula I said, from base one formula I said, yes no, from base h by 4, from vertex 3h by 4 I derived that one, correct. So this one I'll derive here. So what is the position of center of mass from vertex, okay. Here radius of this one is capital R and height h. One small element I have taken here, the element is dx. The distance of this element from vertex is x. Here I'll take two triangles. So this is vertex o, from here 2 triangles, this small triangle, see this small triangle I'm taking. So small triangle, in that small triangle I am applying tan theta equal to, you know that this whatever, so see this whatever this small element I have taken here, just imagine this small element is, look like a ring, or sorry, disk. So because it is a solid I am talking here, solid continuously mass is distributed, this look like a disk. The radius of this disk is capital R I have taken here. Anywhere we can take, at this point, at this point, at this point, anywhere we can take. So this element from vertex is x. Tan theta, this small triangle I am applying here, small triangle, tan theta equal to opposite by adjacent. Opposite is what? R. Adjacent is what? X. Clear? And similarly, this big triangle I am taking here, see this big triangle, so this one. So the angle is the same for the small triangle as well as big triangle. So this tan theta is equal to s capital R upon, so this is what? So opposite divided by adjacent, h. Okay, we got this one. So I'm equating this one for small r equal to rx divided by cross multiplication rx divided by h. This is one formula, we'll use this one. So in next step, okay. So where center of mass of this cone, the will get, so on x axis will get, or y axis will get, x of this cone, the will get, so on x axis will get, or y axis will get, x axis. So on this x axis only center of mass will get, so that's why I'm using, so the portion of center of mass on x axis, just now I said x dm upon integration of dm. Okay, so this dm is nothing but mass of this element. Mass of this element is what? Mass of this element dm. Okay, first I'll write mass of that element here dm equal to, so how to find this mass of this element is mass per unit length. So okay, sorry, density into volume. Why? Because this is continuously, so mass is distributed, density into volume. Volume of this small element, all right, volume of the small element, this looks like a disk. So volume, density into volume. So volume can be written as area into thickness. Area of this one, that one is pi r square into thickness is what? Dx. Clear? dm, so mass of this element, so density into volume will get mass, density rho, volume of this element, area pi r square. Why? Because the radius of this one is what? Small r, pi r square area into thickness, that is dx. We got so this one, substitute that value here. Integration is from where to where, limits you have to take here from here to, if you have taken element here, so here distance is x, x is varying. If you have taken element at this, sorry, if you have taken element at this point, x is from here to here we have to count. So like that, x is varying. Okay, so just limits are from where to where here, limits are from 0 to h, all we are going to integrate 0 to h. Yes, integration x rho pi r square into dx upon integration of rho pi r square into dx 0 to h, 0 to h. Here which one is constant? Okay, and to integrate in any equation, integrate only variable should be only one term. Here only variables, how many terms are there? X also varying, r also varying, correct? Why? Because if you had taken one element at this point, if you had taken element at this point, radius changed, increased, and distance also changed. So like that, in this equation, so variables are 2, so that's why variable should be 1. So rho pi get cancel, keep as it is. So this is integration of 0 to x, 0 to h r square dx upon integration of 0 to h r square into dx. From equation number 1, from equation number 1, xcm 0 to h, what is the value from 1? R x upon h. Just I am substituting the value of r because we should have only one variable term. That's why I'm replacing this r. So r value capital R x divided by h. We should have only one variable term. That's why I'm replacing this r. So r value capital R x divided by h and whole square into dx. Correct? Upon same r x upon h whole square into dx. Now, so which one is common here? xcm equal to xcm 0 to h limits. Here r and h is common. Yes, rh is common. Square into x. This is x cube into dx 0 to h into dx 0 to h upon. Here also r by h is common. Integration of cancel. And this is xcm equal to integration of x cube is nothing but what? X raised to 4 upon 4. Limits are 4. Limits are from 0 to h. Denominator x cube divided by 3. Correct? Integration from where to where? 0 to h. Then xcm is equal to upper limit minus lower limit. Upper limit h raised to 4. And here denominator h raised to 3 divided by 3 divided by 3. So now here xcm is equal to 3. So here h raised to 4 and h raised to 3. So 3 h's will get cancelled, only 1 h left. So this 3 will come on 4. This one xcm, this is the portion of center of mass from where it is, from vertex. See, from vertex. So we got here 3h by 4. So if you are going to find from base, what is the formula? H by 4. So if mass is distributed continuously, we have to use this formula. This formula you have to use. So x dm upon r dm. So if you use that one, you'll get so portion of center of mass of any object you'll get. Yes, here one example. So position of center of mass of 4 particles we have to find. So they have given this diagram. So it is look like a parallelogram. So one side is A, another side is B. If it is B, this also B it is. If also B, and this parallelogram make an angle theta. So first we have to find coordinates. Coordinates of center of mass we are going to find here. Coordinates of center of mass, this is 0, 0, and this one is what? So x-axis a, 0, a, 0, and coordinate of this one is what? Okay, this angle theta. So from here to here, this is b. Okay, so I'll write here c. This is angle theta and this one is b. So if it is b, so what about this length? Yes, this we can write. Okay, so this is x coordinate for this. This one is y coordinate of this particle. Okay, so let's take a cos theta. Cos theta is equal to what? X by b. X is equal to b cos theta. B cos theta. It means that this distance. So this distance from here to here, only this distance is what it is. This distance is b cos theta. B cos theta. Okay, similarly let's take sin theta. Sin theta is equal to what? Opposite by hypotenuse. Y is equal to b sin theta. B sin theta. So next this one, this distance is b sin theta. So therefore coordinates of this particle So x coordinate is what? X coordinate is this one, y coordinate is this one. X coordinate is b cos theta, y coordinate is b sin theta. So this particle. So let's calculate this one. Okay, x coordinate from here to here. So from here to here, this is what it is. From here to here, a, and from here to here, b cos theta. You can write now. So the x coordinate a plus b. So the x coordinate a plus b cos theta, comma. Why? Because if it is b cos theta, this is also b cos theta, a plus b cos theta. And what about this one? B sin theta, sin theta, b sin theta. So now how to find center of mass, coordinates of center of mass? First one, xcm is equal to, so how many particles are there here? 4 particles are there. So that's why m1 x1 plus m2 x2 up m2 x2 m3 x3 plus m4 x4 upon m1 plus m2 plus m3 plus m4. Then xcm is equal to, all are identical, mass same. I have taken mass m common, x1 x1 0 plus x2 is what? A, correct? X2 is a plus. So then x3, this is x3, a plus b cos theta plus x4 b cos theta upon how much? 4m, all are identical. So now xcm equal to is 2b cos theta upon this m get cancelled, this is 4 equal to 2 is common, 2 ones are 2 twos are, this is let's take a 2 common, 2 ones are 2 twos are, we can write here a plus b cos theta upon 2 ycm. Okay, ycm, okay, ycm same. So I'll write direct, m is common, m is common. Okay, y1 is what? 0, m1 y1 m2 y2 m1 y1 m2 y2 m3 y3 like that. So m first one is 0, so second one also 0, third one b sin theta plus also b sin theta, it is 4m, m get cancelled, ycm is equal to 2 b sin theta upon 4, ycm is equal to b sin theta upon 2. Yes, this one. Okay, so like that if you are going to find RCM, one formula, general formula is there here. So see, so I forgot to say in that beginning, RCM is equal to square root of, can write here, xcm square plus ycm square. So you will get r distance. So distance from here to RCM will get xcm square plus ycm square if you are going to find a magnitude. Okay, so like that we can find. So now next example, here 2 discs are there, same thickness and same material. Same thickness and same metal means density is same. Radius and same material, same thickness and same metal means density is same. Radius of first one is r1, radius of second disk is r2. from here to here R2, from here to here R1. Okay, R1. We are going to find center of mass of both these two disks from this point, smaller disk. Sometimes they ask from so big disk, sometimes they ask so small disk. When they'll ask, when they'll give disk, so mass is directly proportional to what? Area. Disk, if they ask, means mass is directly proportional to area. See, so this is mass directly proportional to area. Mass is directly proportional to area. Okay, first mass of first one m1, or also we can write m1. Mass of second, or also we can write m1 proportional to r1 square, also we can write, because pi is constant. And similarly mass of second one is m2 proportional to what? R2 square, we can write this one r1 square, this is r2 square. Now the position of first disk, I have taken this one as a origin. We can write it is x1 is equal to 0. Clear? Because center of mass of this first disk lies at origin.